Good morning, students. Welcome back to Physics Marathon class. I am Puneet Kathuria, your physics faculty at Aakash. So today we are here to discuss AIATS Plus Phase 2 Mock Test 5 that happened or conducted on 16th February 2025. So welcome back to this show, and here we are starting with the questions or concepts which you people have committed frequently wrong. So these questions are committed wrong by most of the students. So we are here to discuss concepts around those questions. So let's understand, or let's have a look at those topics what we'll be covering in this episode of Physics Marathon class. So what these topics are? So these topics are from system of particles and rotational motion. So this would be your first topic. Then questions involving from moving charges and magnetism, that is your second area. Then the third chapter we'll be dealing with is EMI, electromagnetic induction. The fourth, dual nature of radiation and matter. And the last topic, thermal properties of matter. So these are the prime areas around which we'll be keeping our discussions, and we'll be building up concepts and attempting those questions which you people have attempted wrong. So welcome back to this show. So very good morning to all the kids. Vishnu Deep Singh, physics revision. How to do physics revision? It's very easy. Keep everything intact in writing only. Keep memorizing all the shortcuts and the formulas what you people have learnt over a period of time. So if you are ready with your dimensions, units and your formula chart, so most of the things will be managed from that particular part only. Or whatever you do, be confident, have confidence in your preparation, and this is the only Guru Mantra I can give it to you. So let's, hi Pankaj, how are you? Divya Goyal, Jatin Mehta, Ronak, Janak, then we have NIDS, Vishnu Deep Singh. So welcome to this class. So let's start with the first question of this session. A charged particle moves in a circle perpendicular to magnetic field. The time period of revolution is independent of. Now first we try to understand the concept when a charged particle enters a magnetic field. So the force experienced by charged particle is given by QVB sin theta, and this is a vector quantity, so we must put a vector sign over there, and this is the one which is perpendicular to the plane containing V and B. The other way to write down the expression for the force is as cross product V cross B. So this is the basic concept when a charged particle enters a uniform magnetic field. Now important is when theta is 90 degree, we know sin theta sin 90 degree is basically equal to 1, and your charged particle will experience the maximum force. So what this maximum force is QVB, and the direction of this force, we can understand the direction concept using your cross product concept also. So this is V cross B. Let's suppose charged particle enters with velocity V along x-axis in a uniform magnetic field that may be proposed along positive y-axis, that is J. And we can understand I cross J is what? K. So direction of force would be such that it is perpendicular to your velocity vector and perpendicular to your magnetic field vector. So this is how we define the direction as per the cross product rule. But we have already got the magnitude because theta is 90 degree. Your charged particle has entered into uniform magnetic field perpendicularly. So this maximum force experienced by a charged particle, so this magnetic force will provide you the necessary centripetal force. So this is mv square by r. So this is the expression for force experienced by a charged particle, and this force is being observed as centripetal force. So this is a two-dimensional concept, and the radius followed that is called its trajectory, because we have already stated this trajectory would be a circular trajectory, and this r comes out to be mv by qb. But your question is regarding the time period. So this is the expression. Now what is time period? Time period is 2 pi r by v, and when you put the expression 2 pi, so put the value of r as mv by qb, and this v is there, so it goes with this. So what you are left with, that is 2 pi m by qb. So your expression for time period is 2 pi m by qb. So this is the required expression that will help you to answer this question in one shot. So what was the question? Time period of revolution is independent of. So if you just look at this, does it depend on magnetic field? Yes, it does. Does it depend on the charge of the particle? Yes, it does. Does it depend on the mass of the particle? Yes, it does. Does it depend on the velocity of the particle? Now look at this. Is there any velocity expression you can see? I think there is no velocity. So your time is independent of v. So this is the required answer. So let's pick the option 4 as the correct answer for this question. I think I have managed to explain you the concept revolving around the same numerical, and based on this concept you can answer questions related to all these kind of concepts. You can be asked to define the trajectory, you can be asked to compare the trajectory of two particles, that may be two different particles, maybe proton, maybe with alpha particle. So all these questions you can answer it from this area. Any doubt? Virinder Kumar, very good morning. Ajay Singh Rathore, very good morning. Janak screwdriver wala, amazing, very good. Mukesh Kumar Mishra, very good morning. So any doubt? Anyone wants to ask anything, or shall we move? There is no doubt, no question. So let's move. Now the next question is again from an interesting area. A coil having area of 4 meter square is placed in a magnetic field which changes from 3 Weber per meter square to 8 Weber per meter square in an interval of 4 seconds. The magnitude of average EMF induced in the coil. So this is very interesting situation. Magnitude of average EMF. So I am talking about average EMF as so this is rate of change of magnetic flux with respect to time. So shall I put it as, for the average one, we say total change in flux over total change in time, what we can write down as d phi by dt. So this is the basic expression for average induced EMF, that is rate of change of flux with respect to time. Now there is an interesting concept. If you consider the direction as per your Lenz's rule, then induced EMF should have been minus d phi by dt, or rather because they are asking about average, so we can make use of delta also. Instead of, we should put it as delta. And here as per the Lenz's rule, when they are saying Lenz's rule, so we need to consider the negative sign, and this negative sign basically defines the direction of induced EMF. And Lenz's rule clearly says the direction of induced EMF is such that it always opposes the cause of change of flux. So that is the importance of negative sign. And this negative sign is not there in the question because they have asked you to find out the magnitude. So magnitude is delta phi by delta t, because they are talking about the average. Now what is this flux? When they say flux, flux is B dot A, where A is the area vector, or we can simply put it as BA cos theta. And if you have n number of turns in a coil, so that expression would become NBA cos theta, and this theta is basically the angle between magnetic field vector and area vector. So that is also defined, the angle between magnetic field vector B and area vector A. You got it? And if theta is 0 degree, we understand cos 0 as 1, right? So now let's come back to the same question. When they say average EMF, I would like to add on a few more areas based on the same concept, so that you can actually not being able to solve this numerical, but you can solve all the questions revolving around the same concept. So we know average EMF is given to you as phi 2 minus phi 1 by T2 minus T1, and we know flux is given to you as NBA cos theta. So first you try to identify what factors can change your flux. Phi will change if you change the number of turns in the coil. It depends on the magnetic field. So if you change magnetic field, it depends on the area of the coil also. So flux would get changed if you change the area, and definitely with respect to theta also. So it means if you change your angle, that angle we have already stated or defined as angle between your magnetic field and your area vector. So these are the 4 prime factors that may define the change of flux. But here question is giving you the change in magnetic field from 3 Weber per meter square to 8 Weber per meter square in an interval of 4 seconds, and area of the coil is 4. So B2 is 8 Weber per meter square. The other unit, I am just helping you to remember the unit, that may be Tesla also, and your B1 was actually 3 Weber per meter square. Then area is your 4 meter square. Let's verify, area is 4 meter square and time is 4 seconds. So once you have understood the concept, once you have understood or you have developed the formula for the rate of change of flux that defines your average induced EMF. So what is the value? So number of turns, change in magnetic field, area, and cos theta I am putting it as 1 for the change in time. So do we have any number of turns defined in this? No, just a single turn coil. So N, capital N is also 1. What is B2? B2 is 8. What is B1? 3. What is change in time? 4 seconds. What is the area of the coil? 4 meters square. We have to be very particular while solving all these varieties of numericals. We have to keep all the variables involved in the standardized SI unit. So if you keep this important factor while attempting all the numericals, so there is no scope of giving or getting a wrong answer. So it goes with this and you have 5. When we are saying it as an induced EMF, it means what? It means we are talking about EMF. So what are the units for the EMF? Volt. So unit for EMF is volt. So that is the answer, 5 volt. So let's check the answer. Yes, this is 5 volt. I hope we all have understood the concept also, the key area, the important factor we need to understand, and though we have solved the numerical also. Any doubt from this part? Any doubt? Ajay Singh Rathore, crystal clear. Thank you, Ajay. Any doubt? So anything you would like to understand or clear your doubt? Then I think we should move on. Now we have next question. So this question is also very interesting. It says photoelectric emission occurs only when the incident light has more than a certain minimum value of. So what do you mean by photoelectric emission? So emission, we understand it as like when an electron is out of your atom completely. But how? Photo stands for photon, and photon being a particle of light. Electric, so what are the consequences once a photon strikes a surface and helps you for the emission of electron? So photoelectric emission. So when light of suitable frequency, and this frequency has to be greater than threshold frequency. You know, this frequency can be replaced with the another word called energy. Greater than threshold frequency or threshold energy. Then electron will be emitted from the surface of that material. So this definition itself gives you a clear hint. I'm talking about energy. Threshold energy or this threshold frequency, this is the minimum energy. What minimum energy is required to eject an electron completely from the surface of a material? That is called basically the threshold energy, or sometimes we call it as a work function also. So it clearly says when this energy or this incident frequency is greater than what? Greater than threshold frequency, the minimum frequency that is required for this phenomena to happen, that is called photoelectric emission. So this definition has clearly stated the answer, and that answer is well hidden in this concept. Are we talking about wavelength? No. Are we talking about intensity? No. Are we talking about frequency? Yes, definitely. And are we talking about power? No. So we are talking about frequency. And this photoelectric emission follows your Einstein's photoelectric equation. And this photoelectric emission says this is your h nu is basically, h stands for Planck's constant and nu is your incident frequency. So incident frequency. So h nu defines the incident energy, and this has to be greater than h nu naught. This is basically the threshold frequency, or we can write down this one as phi naught as work function also, plus whatever extra energy that is being provided by this photon to this electron. The rest of the energy will be carried by the photoelectron that is being emitted due to this phenomena of photoelectric emission. So that energy will be carried by photoelectron as its kinetic energy. So this is the complete equation, and this equation can also be written like this. So this is the complete expression. We can understand it as Einstein's photoelectric equation, and I must say this equation itself is very, very important, and this photoelectric emission basically defines whether the process of emission will happen or not. So it will happen only when this incident frequency is greater than your threshold frequency. So again, I am highlighting the definition, I am highlighting the importance of this energy. So this question is, we are talking about a certain minimum value of frequency that defines the energy. Any doubt from this part? Shall we move? Any doubt? Prithvi, yes. Jatin Mehta, can photoelectric effect cause emission of beta particles anyhow? What do you mean by beta particles? When the beta particles will be there? Photoelectric emission, basically we are talking about as the phenomena, because when photon strikes the surface, it emits electrons only. For the beta particle emission, you have to get into the details of your nuclear reaction, because that involves the nuclear processes. So that is something different. Jatin, I think you need to understand more about your emissions. What is this photoelectric emission? Here we are talking about photoelectric emission that deals with the photoelectrons only, and beta particle is something which is altogether different, that involves your nucleus. So anyhow, any more doubt you have? I think we should move then. Yes, this is again related to the same topic of photoelectric emission. In a photocell, magnitude of saturation current depends on intensity of incident light. Now there are key areas keywords saturation current and intensity. So if you understand these two words, I think that would help you to understand the concept and will help you to understand or will help you to give the answer correctly. So let's focus primarily on the assertion part only. So the very first assertion says, in a photocell, magnitude of saturation current depends on intensity of incident light. So first you understand the word intensity. For a general term for any wave, intensity is defined as amount of energy incident per unit area per unit time. This is the general definition of word intensity, and that is to do with the waves. We can define intensity of any of the energy or any of the wave. But here in context of photons, so intensity is defined as number of photons striking per unit area per unit time. And we know photon being energy packet of your light. So energy carried by the photon is again h nu only. We have just discussed in the previous question. So here intensity we are talking about is number of photons striking per unit area per unit time. It means we need to understand this photon collides with your electron, and these collisions are elastic in nature and helps you to eject photons. So here we are talking about particle one-to-one collision. So this involves particle one-to-one collision, and we know these are basically your elastic in nature. So here one particle is your photon, it collides with electron, and this collision may or may not result in the emission of the electron. So if this energy is definitely greater than this one, we know emission will happen, and if this energy is less than that, collision will happen, but that may not result into the emission. That will result into the excitation of electron only, and electron will not be able to stay in the excited state, will fall back with the emission of maybe one or maybe more than one photon. That depends. That is the probability number. So this emission will happen only when this incident energy is greater than threshold energy. So this electron so emitted, so once you have the emission, these electrons emitted are called photoelectrons, and they start moving through that material. So that constitutes photoelectric current. So if you understand photoelectric current versus intensity, we know intensity is number. So one number collides with one particle and helps you to emit one particle. If 10 photons strike, that helps you to emit 10 electrons. If 100 photons strike, 100 electrons. It means the more is the intensity, that means more is the number, more is the intensity, more are the number of photoelectrons emitted, and more will be the current. So that is directly proportional. So this is how photoelectric current varies with the intensity. Now once the photoelectrons, whatever photoelectrons are available in your cathode, if all the photoelectrons are emitted, that is called saturation stage. So it means if intensity is more, the number hitting would be more. If number hitting more, intensity more, it means more photoelectrons, and definitely once all the photoelectrons are emitted, and that stage is called saturation current. So that depends directly on the intensity. So in a photocell, magnitude of saturation current depends on the intensity of the incident light. This assertion is correct. I hope we have understood it. Okay. Then next one is, if the separation of the source of the light from the photocell increases, then the magnitude of stopping potential remains same. So for understanding the concept of stopping potential, let me just work out with your Einstein's basic equation. H nu is equal to H nu naught plus kinetic energy, and this kinetic energy can also be written as charge times stopping potential. That is there. And we know for a given material this value is fixed. It means what? It means stopping potential depends only on the frequency of the incident radiation, depends only on the energy, frequency, not on the intensity. So it says if the separation of the source of the light from the photocell increases. So first we need to understand, does this separation changes the frequency of the incident light? Does this? Answer is no. So if there is no change, then the magnitude of stopping potential what? If there is no change in this incident frequency with the separation, it means stopping potential would remain same because the incident frequency remains same. So this assertion and this reason both are correct. So both assertion and reason are true, and the reason is the correct explanation. No, reason is not the correct explanation. So shall we say both assertion and reason are true? So both are true, but reason is not the correct explanation of the assertion. And this is the correct option we have. I hope. Okay. So there is question. I hope we have understood it. Let me just answer one of the questions we have received. Difference between, it's not AIATS plus, it's AIATS, All India Aakash Test Series, and normal and plus. So we have two versions. AIATS, which have been there since more than a decade now, and that is the quality benchmark that has been set by your Aakash. Now what is this plus is? So we have added one more feature. AIATS is no doubt one of the best way to analyze or to understand your All India ranking, that helps you to perform really well. But what this plus is? So plus stands for personalized learning for ultimate success. So this plus basically caters to your individual or a student's individual performance. Let's suppose a student has done some questions wrong. So his weak areas are different from a student who has attempted different wrong questions. So just to address that need in a more personalized way, we have added. So for every wrong questions, you people will be provided your questions to practice as per your committed mistakes. So that will not be a generalized mistake, rather that would be your personalized analysis, and services will be provided to you according to your personal mistakes, as per your personal requirement, as per your individual needs. So this is the main difference. Plus you have all these features which are being added to, like you have live sessions, discussions for all these. Then we have personalized evaluation with all these personalized focused questions which are there. So these are the some of the features. So I think we should move on. Very good morning. So if you have understood it, shall we move? Now, the basic purpose of teaching you all these is not to cover your just numericals, help you to understand the concept revolving around those numericals, so that if you come across the same variety of question again even in your NEET, so these concepts whatever we are building up, concept by concept, question by question, these concepts would help you to understand all these areas and would help you to perform really well in all the questions which you may find it related to all these questions. So that will help you to perform really well. Now we have two rotating bodies A and B, moments of inertia IA and IB have equal kinetic energy of rotation if LA and LB be their angular momenta respectively. Then now first we are talking about rotational kinetic energy. So rotational kinetic energy. Most of the students, they don't remember even the formula for the rotational kinetic energy, but I would give you a trick where you can retain all the formulas, and that trick is like you people know your general concept of translational kinetic energy, which you people have been using since your junior classes. So this everybody is aware of it, half mv square. So same way we can understand. So what is the formula? Half. So what is the counterpart of mass? So what is there in the mass in translation motion? So we have a same analog. So mass is being replaced by another term called I. I is moment of inertia. So moment of inertia plays the same role what mass does it in translational motion. Then instead of V we put it as omega. So this is half I omega square. So that is a formula for the rotational kinetic energy. Then we need to understand angular momentum, and then we need to understand. So if you remember, the kinetic energy can also be written like this. So here kinetic energy is p square by 2m, where p is your linear momentum. So what is the rotational analog for this word? That p is replaced by L, that is called angular momentum. So L square 2m, m is I in rotational concept. So this is the concept of rotational kinetic energy. So now we have understood the formula, and we got the trick also to remember or to write it down. So this is the formula what we are actually looking for to answer this question. Any doubt up to this? Tanmay sir, I took 5 minutes in this question. Okay. Now Tanmay, once you know the formula, then there is, it will not take much of the time now. It says two rotating bodies A and B of moment of inertia IA and IB have equal kinetic energies. So let's understand for the body A. So this is the rotational kinetic energy for the body A. Same way में rotational kinetic energy for the body B. And it says these two rotational kinetic energies are same. You got it? LA and LB. One more information, IB is more than IA. So if IB is more than IA, it means just by looking at this, LB has to be more than LA, and this is the one. So this is the power of retaining all the formulas, because physics, most of the question revolves around all the formulas. So once you have understood the formula, once you retain the formula, once you know the formula, you can understand or you can solve it in no time. I hope, Tanmay, I have answered your question. Any doubt? Any more doubt? Shall we move? Okay, fine. Good. So this way you can compare, rotational kinetic energies of, so you may have varieties of numericals revolving around the same rotational energy concept. So I think now with this understanding, you'll be able to solve more variety of numericals. So let's move on. Yes, when a solid melts into liquid. So this is another question. So we know we have solid. We need to understand how this phenomena happens. So let's understand with the help of one graph. So here I am talking about time, and let's understand temperature versus time graph for this process. This is quite interesting. Why I am teaching you this way? Because this way you will get to know more concepts in the shortest possible way, varieties of concepts, and that would help you to solve varieties of numericals. So when you start heating a body, what happens? Body will absorb heat and its temperature keep on rising. And you know, at this stage, the amount of heat absorbed, if I label it as Q1, so that would be mc delta theta, where m is mass of that solid, c is specific heat of that solid, and delta theta is rise in temperature. So first body absorbs and its temperature keep rising, and this continues for some time. But after one stage, we know when you keep on heating, ultimately a stage will come when solid will become liquid. Let's do it this way. And you know, this process is basically called melting. So this is the one. Do we absorb heat during this process? Yes. Body will continue to absorb heat, but if you look at this, its temperature remains constant. And you know, this is a very interesting case. The amount of heat absorbed by the body for this phase transition from solid to liquid per unit mass, that is called its latent heat, that is L. So it absorbs heat, no doubt about that, but that heat will be at constant temperature. Why temperature remains constant? Because heat is used to overcome the potential energy, and it's not increasing the kinetic energy of the molecules. So molecules, when they do the phase transition, they just overcome this attractive forces, these cohesive attractive forces. It means they have to overcome only the potential energy, and this amount of heat absorbed is Q2, and that is latent heat at constant temperature. Then you continue to heat, body will continue to, and its temperature keep rising. And at this stage, body has already attained the liquid stage. So we are at the liquid stage. So third heat would be mc delta theta again, but this time your C is specific heat of the liquid, and finally you will attain a stage that means again at constant temperature. This temperature was like melting point. This temperature now it is boiling point, and the amount of heat it absorbs, because here we are talking about the phase transition from liquid to gas, and this is mL, where L is latent heat of vaporization, whereas in this case latent heat of melting was there. So this is the complete process, and you can understand it how this body has continued to absorb heat when its state remains same, solid, and at a particular stage when it absorbs heat Q2, its phase transition happened from solid to liquid. Then again from it continues to absorb heat even during the liquid stage only, and that is liquid stage. Specific heat involved is latent heat of that is specific heat for the liquid, and finally for the Q2 when liquid is getting converted to gas, that is latent heat of vaporization. So now let's coming to the question, when a solid melts, does it absorbs energy? Definitely yes. Let's check. It releases energy? No. Its temperature increases. When a solid melts, no, we have just stated its temperature remains constant, because here we are talking about the phase transition, latent heat. So temperature remains constant, so that is also wrong. Its temperature decreases? No. So the correct option goes for it absorbs energy. So I hope we have added some more to your knowledge as far as this phase transition is concerned. Anything? Tanmay is asking, why does the time for phase change increases like for melting? Bacha, this is very important when you keep on adding heat, when you keep on adding energy. So definitely with passage of time only you can add more energy. If you add more energy, it will take more time. So time has to be in forward mode only. It has to be keep increasing. So temperature will remain constant during the phase transition, but time will continue to increase. So I think you got the answer. Any doubt? Shall we move? Which of the following vector relation is incorrect? So this is really something important. So V is omega cross R. This is a cross product. This is fine. Torque. Do we have F cross R? Torque is R cross F. This is how it is defined as cross product of this position vector and its force vector. So RF sine theta. L, angular momentum R cross P. This is perfectly fine. Work done being a scalar quantity, we write it down as a dot product F dot D. So this is also correct. So your question was incorrect. So definitely the incorrect option, which is wrongly written in cross product form, that is for the torque. So there is not much to be discussed in this region. So I think we should move on. Yes. Next question is, a cup of tea. A cup of tea is kept on a table. Fine. If it cools from 80 degree to 75 degree in T1 minutes and from 75 degree to 70 degree in T2 minutes, then first here we are talking about a rate of cooling. So that is defined by Newton only. So we are talking about Newton's law of cooling, that defines this concept beautifully. So it says rate of change of temperature with respect to time, and this temperature keeps on decreasing. That is why we are putting a negative sign. So Newton's law of cooling says it depends on the temperature difference. That is temperature difference of what? Temperature difference of absolute temperature of the body with respect to surrounding temperature. So that is T naught. So, and you know, with time, this rate keeps on decreasing. As you move closer to your surrounding, the rate of cooling keeps on decreasing, because initially when you have a temperature of your absolute temperature of your body that is more with respect to your surrounding temperature, rate of cooling would be initially fast. But as body keeps on cooling, its temperature difference with respect to surrounding keeps coming down, keeps decreasing. So that is why rate of cooling would definitely be slower with passage of time. So it says 80 to 75, though there is a temperature difference of 5 degree in T1 minutes, but body has already lost some energy, body has already lost its temperature. Now it is being closer to your surrounding temperature. Though surrounding temperature is not mentioned, but we can keep it as room temperature only, that is close to 25-30 degree, and it cools from 75 to 70 in time T2. And this graph or this expression clearly states that rate of cooling would be on the lower side, would be decreasing. So it means your time would be, body will take more time to have the same fall in the temperature. So definitely T2 is more than T1, and this is a conceptual case. And this area I would like to highlight, this is one of the important areas for your NEET part also, and you may have a numerical calculation. If I give you T1 and T2 and your surrounding temperature, then you may be asked to calculate any of the variables. We may be asked to, if T1 is known to us, we may be asked to solve for T2 also, the actual time taken by the body to decrease or to lower its temperature from 75 to 70. So this is the concept. Shall we move? Now, the ratio of de Broglie wavelength of proton and alpha particle of same kinetic energy is, this is again one of the important areas. So first we need to understand de Broglie wavelength is defined for all the matter waves, and it has a significance only for microscopic particles. For real life situations, it has no significance. So this is defined as h by mv, that is momentum. And we know momentum of a body. So if you remember kinetic energy, if I write down kinetic energy as E, in the previous questions we have showed it as p square by 2m. So what this momentum? Momentum can also be written as 2m times kinetic energy under the root. Got it? So this is the required expression that will help you to understand the same question. So it says de Broglie wavelength of proton. So proton is basically hydrogen atom H11 and an alpha particle, which is your helium nucleus. So it says they have the same kinetic energy. So this E is same. So shall I say this de Broglie wavelength is inversely proportional to root of m? So let's compare for proton and for alpha particle, and as per this formula it should be mass of alpha by mass of proton under the root, because it follows the inverse square root function. So what is mass of alpha? We know mass of alpha is 4 and mass of proton is 1, and when you take the root, this is 2:1. So that is the required answer, 2:1. Any doubt from this part? So let's move further. The magnetic field dB due to a small current element ideal at a distance r. This is basically your Biot-Savart law. It says the small magnetic field can be written as mu naught upon 4 pi I dl sine theta by r square. Got it? And if I put it as this one, that depends on the direction, and that direction is given by your right hand rule. So that may be in the plane or that may be above the plane, that is decided by the direction of the current. So we can simply put it like this, n cap, just to be not sure about this, but this is how we define it as a vector. So when you put it in cross product form, shall we put it like this? We know this r unit vector can be written as vector r by its magnitude. So if you substitute this unit vector r with this expression, so the net expression will be something ideal cross r by r cube only, and this r is the magnitude. So sometimes you can write down magnitude like this also, there is no harm. So we have to pick, this is a direct question, so we have to pick. So do we have the option like this? No. Ideal by r square? No. Ideal r by r? No. Ideal cross r by r cube? Yes. So we got the answer, and this is a direct formula based question. If I would rather suggest you please retain the formula. So this is all from my side for today's marathon part. This is your marathon physics class, and we had just discussed few questions which you people have committed wrong from your AIATS plus phase 2 test was conducted on 16th of February. Again, your faculty Puneet Kathuria from Aakash will help you to understand the concepts in new exams also, or whatever exams you may have. So till then, I would like to say thank you for attending this session and get ready for the next class. So that will help you to understand more concepts, more numericals. Till then, bye, take care. Thank you.